Good day to you, mom. I'm gonna report thing about linear regression. So, linear regression is a process by which the equation of line is found that best fits a given set data. The line of best fit approximates the best linear representation for your data. One very important aspect of the regression lines is the relationship between the equation and the science quantity, often represented by slope of the line. So, in order to solve the problems involving linear regression, it is necessary to know how to enter the data for completing modeling problems, know how to determine slopes of linear equations, know how to calculate linear equation that best fits a set of given data, know how to solve literal equations, recognize the science quantities associated with the slopes of special data sets. Know how to rearrange literal equations so that associated science formula can be used to discover the best interpretation of a slope to the trend line. Know how to write the solved equation for a word problem. So now here are my example of the linear equation examples. Consider the following set of points -2, -1, 1, and 1, 3, and 2. Find the least square regression line for the given data points. B. Plot the given points and regression line in the same rectangular system axis. So let us organize the data in the table. X equals X scores consists with -2, 1, and 3. So the sum of the X scores equals 2. And the Y scores is -1, 1, 2, and the sum of the Y scores equals 2. So the sum of X and Y scores consists with 2, 1, 6. The equivalent of this is 9. And the sum of X squared pairs is 4, 1, and 9. And the sum of this is 14. So now we use our formula to calculate and be as follows. So A equals to the number of pairs minus minus the sum of X scores and sum of Y scores slash n to the sum of squared pairs minus sum of the squared pairs equals 3/9 minus 2/2 slash 3/14 minus 2 squared equals 23/38. B equals 1 to the n pairs close and open parenthesis y square minus a to the sum of x scores equals 1/3 2 minus 23/38.2 equals 519. So now we graph the regression line given by y equals ax plus b in the given data points. So here are the graph example. So next problem, find the least square regression line of the following set of data: -1, 0, 0, 2, 1, 4, 2, and 5. Plot the given data points regression line in the same rectangular system axis. So we use table as follows. So x scores equals -1, 0, 1, 2, and the x scores equals 2. You're gonna and the y scores 0, 2, 4, 5. And the sum of the y scores equals 11. And the sum of the xy 0, 0, 4, 10. So the sum of xy scores equals 14. So the total sum of x squared pairs equals 6. Now use the above formula to calculate and be as follows. The same things before. A equals and y scores minus sum of the x scores and sum of y scores slash n to the sum of squared pairs minus sum of the squared pairs equals 4.14 minus 2.11 4.6 minus 2 squared equals 17 over 10 equals 1.7. B equals 1n to the y squares to the sum of the y squares minus a and to the sum of x squares equals 1/4 11. 11 minus 1.7 over 2 equals 1.9. So now we graph the regression line given. So problem 4, the values of y and the corresponding values of y are shown in the table below. x consists with 0, 1, 2, 3, 4. Y was 2, 3, 5, 4, and 6. Find the least square regression line y equals ax plus b. B, estimate the value of y when x equals 10. We use a table to calculate a and b. Sum of the x scores equals 0, 1, 2, 3, 4, total of 10. Y scores 2, 3, 5, 4, and 6. And the sum of y scores equals 20, and sum of the x and y scores equals 3, 10, 12, 24, the total of 49, and the total of sum of squared pairs equals 30. We now calculate A and B using the least square regression formulas for A and B. A equals and a number of pairs to the sum of x scores and y scores minus x scores and y scores slash n pairs to the squared pairs minus x scores squared equals 5.49 minus 1020 slash plus 530 minus 10.2 equals 0.9. P equals 1 to the n pairs and to the sum of y scores minus a and to the sum of x scores equals 1 over 5. 20 minus 0.9 over 10 equals 2.2. Now that we have the least square regression line equals 0.9 plus 2.2, substitute x by the 10th to find the value of corresponding y. So, problem number 5. The sales of company in $1 million for each year are shown in the table below. X-axis year 2005, 2006, 2007, 2008, 2009. Y equals sales 12, 19, 29, 37, and 45. So, the same thing before. Find the least square regression line and equals ax plus b. Use the least square regression line as a model estimate the sales of company in 2020 result. We now use the table to calculate A and B included the least regression line formula. T2 consists with 0, 1, 2, 3, 4. So, consider the x scores equals 10, y scores equals 12, 19, 29, 37, 45. Y scores equals 142, and t and y scores 19, 58, 111, 180. X and y scores equals 368. The sum of t squared pairs equals 0, 1, 4, 9, 16, total of 30. Now we calculate A and B using the least square regression formula for A and B. A equals n to the pair of n pairs t to the sum of y scores minus t scores and to the sum of y scores and t squared pairs minus t squared pairs equals 5 over 368 minus 10 over 42. So 5.30 minus 10 squared equals 8.4. So let's proceed to letter B. 1 and to the n of pairs close and open parenthesis to the sum of y scores minus a and to the sum of x scores equals 1 over 5 close and open parenthesis 142 minus 8.4 over 8.4.10 equals 11.6. In 2012, t equals 2012 minus 2005 equals 7. We now calculate a and b using this correlation. So a to the n pairs to the sum of t and y scores minus t scores and to the sum of y scores slash n pairs and t squared pairs minus t squared pairs equals 5.168 minus 10.142. 5.30 and minus 10 squared equals 8.4. 1 to the n pairs and to the sum of y score minus ax to ax scores equals 1.5 slash 142 minus 8.4 over 10 equals 11.6. And 2012 minus 2005. The estimated sales in 2025 are y equals 8.4.7 plus 11.6 equals $70.4 million. That's all. Thank you.